Hi everyone, I'm Skywaston, and in this video series we are going to make a simple first person shooter game in Godot. So as you can see, it has all the basic stuff here. We have our enemy which is following us. We are making use of nav mesh so that it deals with collision detection and all that stuff. And once we have cleared out all the enemies, we can go on to the next level. And over here, let's try having many sets of different enemies follow us. And here the Godot's own navigation mesh is being used, so the enemies are avoiding themselves. So obstacle avoidance is being in place. And yeah, so this is the basic the game we are going to make in this tutorial series. In the first part, which is this video, we are going to make the basic player controller, which will have camera rotation and player movement. So let's begin. Let's create a project. I will name it FPS tutorial. You can name it anything you feel like. And I will set the renderer to forward plus. So with the project opened, I will do a little bit of setup. First of all, let's name the main scene and save it inside the main folder. Then I will change the color of the sky and ground. Much better. So now let's run the scene and select the current scene as the default one. Great. Now let's lay out the level. For now I will use CSG nodes to build up the level. The main root node is going to be CSG combiner, and I will rename it to world. Then inside of it I will add CSG box 3D, and this is going to be our ground. So let's enable snapping, and then I will go on to the top view. I can also press 7 on numpad, and this will make it easier for us to design. I will just have it to be 100 units wide and 100 units long. So yeah, this is it, and let's add a material to it. I will make it a little bit of gray. I will also save the material because later on I will add texture to it. So I will save it in a new folder, assets. And let's name it ground. With this done, let's add some obstacles. Let's say wall. And the reason it's a good idea to do this is because when we set up our player controller, if we move ahead, it will not be so easy to see the movement. For that, right now let's have some walls so it's easier for us to see the feedback. Here I will add a material again, and again I will save it and name it as wall, and I will have a dark shade on it. Okay, so this is it, and let's lay out the level. I think for now this looks okay, and with this done, let's go ahead and create the player. So I will open a new tab and have character body 3D as the main node, and let's rename it to player and save it inside of our main folder. I will create a player subfolder and save the scene over here, and let's add a mesh instance 3D. This is for visual purposes, and let's have a box mesh, and I will make it 2 meters long, and now I will add a material to it, and make sure that you add the material in the surface material override. It's a much better practice to do so. So for this material we can have it in within the scene itself. We don't have to save it elsewhere, as I will be using it just for player only, and it's just for visual purposes. So with this done, let's add a collision shape, and here I will use the same box shape, or maybe let's use the capsule shape, as this is much better suited. And we just have to move it. We don't have to change the size because it's by default 2 units long, or maybe I should say 2 meters. Okay, so with this done, we can now proceed ahead and add a camera 3D node. So this will allow us to see the world. So here we are. So I will put it somewhere around here, and on the right side you can see how it's going to be visible through camera. And I think let's also make the size, the X and Z of the body a little smaller. So let's say 0.75. So this way the camera is going to be much better visible. Yeah, and we can do the same thing for the capsule as well. So let's see, let's go with 0.4. Okay, so that is it. So this is our player, and one thing you will notice is that in Godot the forward direction is always in negative z direction, and that is why the camera is pointing in negative z and not over here. So this is going to be our front view, or the front direction. Let's add player in our main scene, and this is it. I will actually move the walls a little bit behind. I just find the default position of player to be at origin 000. Just feels better. Okay, and here we have our player, and let's run the game. Great, so we can see the world. I will do just one little change for now, and that is in our directional light I will disable shadow, because at the moment it looks kind of ugly with shadows, so let it be without it. So yeah, great. So with this done, let's implement camera movement and player movement. Okay, so let's see, I will add a player script over here, and let me zoom it a little bit, and I will name the class as player. Now to make things easier for us, from the get-go we are going to have logic added on the player in separate components. Now it's just for organizational purposes. I won't be using any like specific pattern. It's just for clarity, because later on we are going to add player interaction, weapons and all sorts of things. So having all things in one script is going to be really messy. So yeah, so for that let me create a new folder within player, and I will call it components. And inside of it I will add a new script. Let's call this camera manager, and let me just prepend player over here. Okay, so let's call it player camera manager, and it's going to have the following function. For ready it's going to be start. For update it's going to be for process is going to be update. For physics process, physics update. Now for this we can actually define a base class, but I'm not going to do that. I will just restrict itself to like, we can do that, it's up to you. But for now I will make a function for input method. Okay, so I will now call it input update, and let me show you which method I'm talking about. So if we go to player class, we have this input event function. So inside of here we will going to call the player camera manager's input function, right? So this is the type of event. Okay, so yeah, this is it. And let's add a reference of our component inside of player. So let's call this camera manager. So here I will just pass on event, and inside of our input update let's now implement camera movement. So for camera movement, what we actually need to do is set up our camera in such a way that we don't have to basically rotate the camera itself, as rotations often makes things trickier. So that's why we are going to add uh, a parent node for it, and let's call this camera root, and it's going to be of same position as our camera. So I will copy this position and paste it over here. Great. And now make camera 3D the child of camera root. So with this done, let's see how the movement is going to be, or rather I should say rotation. So for rotating our player, for horizontal rotation we are going to rotate it around the y-axis, which is up arrow over here, and it's going to be us rotating the player itself. And for the vertical rotation, which is going to be around the x-axis, we are going to rotate our camera root node. Okay, so let's do that. So first of all we check if our event is input mouse motion. So if that's the case, we are going to rotate it by some amount, and that some amount is going to be the amount by which the mouse has moved since the past frame. So we can check that if I say event dot relative, and we can control click it and see what it says. It's the mouse position relative to the previous position, which is position at the last frame. Okay, so let's run the game. And yeah, of course we have to add the player camera manager node inside of our player scene. So let's do that. I will add a node scene and name it components, and inside of it I will add another node, and let's name it camera manager, and I will drag in the script and then select player node, and in our components select player camera manager. Okay, so let's run the game. And so you can see, as I'm rotating the mouse, we can see the result being printed out, and it only prints when we move the mouse. So say if I move the mouse towards the left, you can see the X is negative, and if I move it towards the right, the X is positive. In the same way, if I move the mouse upwards, the Y is negative, and if I move it downwards, the Y is positive. Okay, so yeah, that is it. And the reason why is positive downwards is because in Godot the positive Y is downwards, because this is the origin, and the positive X is right and positive Y is downwards. So yeah, so we will use this value to rotate the camera. So first of all, let's rotate our player itself, which is going to be the horizontal rotation. So if I type in, and also we have to add a reference to the player itself, so let's do that. Now of course we can do something like say if we had a player, we can do this as well, and this will just work fine, but I will make it a little bit more explicit. It's just something I feel like doing. You don't have to do that. You can just use owner to refer to the player. So with this done, let's rotate the player first of all. So we are going to say player dot rotate y, and for the angle it's going to be event dot relative dot x. So let's try this out. And of course I forgot to add reference of the player, so let's do that. And now let's see. Okay, so it's working, but the speed is way too much. So for that we can have something like mouse sensitivity, and let me just make it a little bit nicer so that our inspector is much more easier to read. And I will put it at the top, and let's multiply the rotation amount by our mouse sensitivity. Okay, let's see now. Okay, so I also have to make it have it some value, because by default it's going to be 0. So let's say 0.1. Okay, so it works. We can reduce it a little bit. Let's make it 0.01, and also let's make it negative, because right now the rotation is inverted. Much better. And also let's do one more thing. You can see that while rotating we can see the mouse, and it's kind of distracting. Okay, so inside of our player script, inside of ready, we can say input dot mouse mode equals to input dot mouse mode captured, which basically what it does is that puts our mouse cursor at the center and hides it. So now the rotation is going to be much more easier for us. Now with this done, we are going to rotate the camera root. So let's add a reference to camera root as well. It's going to be cam root, and let's rotate it. Now it's going to be around the x-axis, and it's going to be negative event dot relative dot y times mouse sensitivity. So now if we see, and okay, again we have to add a reference. I always keep forgetting that. So I'm sorry, it's actually going to be Note 3D because we are not rotating camera. Okay, so inside of our player camera manager, it's going to be camera root. Okay, nice. So let's run the game again, and much better. Now it's done, but there's just one little thing that we have to do, and it's that if we rotate horizontally, it's good, but if we rotate vertically, then if we keep rotating it like this, you can see it's like we need to add a limit to it. Okay, so for that we just have to clamp the value, so the camera can't rotate beyond 90 degrees above and below. So for that we can simply clamp it by setting its rotation dot y again with a clamped value, and this is going to be let's see, clamp, we clamp the value, and the value is going to be our existing camera roots rotation dot y, and the minimum value can be so let's see, so the minimum value is something which is around 90 degrees, which I think it's fine, and the maximum is again 90 degrees, so we will go with 90. And since it accepts it in radians, so we can just do is do pi divided by 2, and as pi is 180 degrees, which is 3.14 radians, and if we divide it by 2, it's going to be 90 degrees. And similarly, we are going to do this for maximum, and make sure that for minimum it's negative pi by 2. Alright, so let's run the game now, and it's okay, so just a second. Okay, my apologies, we have to clamp the x, so it's not going to be y, it's going to be the x. Okay, and yeah, much better. So with this done, we have finished our camera rotation implementation. So now let's begin with our player movement. So for player movement, we are going to create another script and name it player movement, and let's name the class as well player movement. And you will see that I'm naming the classes in Pascal case, that is I'm not adding these the writing is not in snake case, and I'm not sure, I can't remember, but I believe this is how the classes are named. Like we can see the default node how it's named. Yeah, correct. So all these classes are named in Pascal, and I'm also doing the same thing just to follow the conventions. Yeah, just something that came in my mind. Okay, yeah. So let's add a reference to it first. Okay, so we can do the setup. Let's do the initial setup, and it's going to be movement, player movement, and we will add a reference to this. So let's create a new node, and let's name this player movement, and attach player movement script to it, and then finally in movement we reference this script. Okay, so inside of our player movement, let's start by adding gravity. So we are going to have a function which is going to be run inside physics process. Okay, I'm going to name it physics update, and let's call it inside of our main player scripts physics process function. It's going to be movement dot physics update and pass in the delta. All right, now in our player movement, let's define gravity. I will make it exported so we can change it later on by inspector. So for now I will have a value of 10 for gravity. Then so since we are using character body 3D, let's have a reference to player as well, which is the character body 3D, and it gives us the functionality to make the character move and does a lot of physics calculations in a controlled way. It's not like rigid body, but it does a lot of heavy lifting for us. So we are going to be manipulating the default velocity. Okay, so let's do this. So first of all, to update the gravity, we update players velocities y and decrement gravity, and also let's multiply this by delta. And to make it actually work, we have to call move and slide, which is going to be inside of player. Okay, so let's see if I run the game. And again, I forgot that we have to add a reference to the player. And yeah, the gravity is working. It's just that we fell off, and that's because we have to enable the collision on our main CSG combiner node, which is at the top. And now if we see, yeah, we are now on the ground. Let's see how much strong the gravity is. Let me put the player a little bit above the ground, and maybe we can increase the gravity a little bit. Let's make this 20. Maybe we can make it 50. I will go with something like 100. Yeah, I think that's fine. Let me just put it back. Okay, so the gravity is working. So the next thing that we are going to do is add jump, and after that we will add the movement. So for that, let's add some input actions. So I will start off by adding actions for movement. So we can have forward, backward, left and right, and then jump. Now also let's add sprint. So for forward, we are going to use the W key. For backward, S, and so on. For jump, it's going to be space, and for sprint, left shift. Okay, so yeah, this is it. And now inside of our physics update, so right now we are applying gravity all the time, but we only want to do this when we are in the air. So suppose if we are on the floor, so we will do player dot is on floor. Then we will basically allow the player to jump. Otherwise, when we are in the air, we will be applying gravity. So for jumping, we basically what we do is when the player is on floor, we check for the jump input, which is space key, and whenever we press the jump action, we are going to set player's y velocity to some value, and we can define it over here. So let's do export var jump speed, and let's make it let's say 25. And you can also do something like maybe plus equals to, but I find just directly setting the velocity, directly changing it feels much better. So yeah, so it's going to be now jump velocity. Now by the way, usually when you are on the ground, then velocity is most likely already going to be 0. So yeah, it doesn't make much difference whether we do plus or not. Yeah, so with this done, I will just do one little addition, which is, let's make it a little bit nicer. And I will put this above. Okay, so with this done, let's run the game and see how it works. Much better. So now we can jump. So let's add some comments over here. So this is the jump logic, this is the gravity logic, and now let's do the movement logic. So for movement, we are going to define input direction vector variable, and this is going to be a vector 2. And let me write down the statement, after which I will let you know how it works. So we are going to do input dot get vector and pass in, and you can see the negative positive x, negative y, positive y. So this should give you an idea. So for negative, we are going to have our left action. So by negative, it means that when we press A, the x of this vector 2 is going to be negative, and when we press D, which is for right, it's going to amount to positive x. Similarly, for negative y, it's going to be actually forward, because as I said earlier, the z forward direction is always in negative z, so that's why. And for positive forward, which is positive y, is actually going to be backwards, so this is backwards. Okay, and the reason is because you can see the default forward is always in negative z direction, that's why. So this is going to give us the input directions, and then we have to convert it into our movement direction. But before doing that, I just want to show you what if we don't do that. So if we just go with something like input direction, so say if input direction is something which is not 0, in that case we can do something like player dot velocity dot x equals to input direction times speed. So let's define speed here, and I will going to make it 10 for now, and let's copy this, and also let's make sure that it's input direction dot x, and then for forward we will use z, for input direction it's going to be y. And if it's 0, we can just make it like this for now. Okay, and let's see how it works. So now if I press W, and for back it's S, for left D, and for left A, and for right D. So it's working great. But you see, if I rotate the mouse and say if I look towards right, and now if I press W, we are actually moving towards the left, and that's because we are always going to be moving in the global directions, which is like the global forward. Okay, and we don't want that. We want that our forward should be wherever our player is facing. All right, so for that we have to calculate that direction, and to do that, what we do is we define another variable which is going to be direction, and we have to make it vector 3, and that's because what we will do is multiply our players transform basis, which is global basis, and I will let you know what this means in a moment. And we multiply this by vector 3, uh, so the x is going to be our input directions x. For y it's going to be 0, and for z it's going to be input direction dot z. Sorry, input direction dot y. Okay, so the way it works is that our basis is basically something which contains the direction for each of our axes. So you can check it out over here, and I'm not fully aware of the internal workings. I always keep forgetting it, but the way it is that if our forward say is looking at some other location, this vector is going to be some unit value. Okay, and similarly for y and x. So what we are basically doing here is that with this, what this multiplication does is that when I say global basis times this vector 3, so we are basically scaling all these each directions by the value of these inputs. Okay, so suppose if I'm not even pressing x at all and I'm only pressing y, so this is going to be 0, and this 0 is going to be multiplied by our basis is x, which is the x vector, which is this. So this is also going to become 0, but because we are moving in the z direction, it will be the default value. So that's how we get the direction, and we just have to make sure that after doing this we also normalize it. So we do dir dot dir normalize, and that will ensure that we get a unit vector, because the basis also contains information like rotation and scale, so that can sometimes have not the actual unit value, but also in certain cases, suppose if we are at the corner, uh, then we will also not get the actual unit vector. Okay, so with this done, we can simply have it as dir x. So we, instead of multiplying by input direction, we multiply this by direction. So dir x, and over here we can do dir z, because we have made it 0 over here, the y, and then we simply call move and slide. And now if I run the game, so it works good. But now if I rotate it, now I can move in the direction the player is facing. I think we can perhaps reduce the sensitivity a little bit more. Much better. So this is it. The movement is done now. I will actually make it a little bit more smaller. Okay. Okay, so I think it wasn't saved. Okay, so this value is working fine for me. Okay, so yeah, so the pretty much most of the stuff in this tutorial is done. I will just do a little bit more, which is I will add sprinting, and for that we can I will actually define a variable which is going to be sprinting, and we will going to use it later for a bit of an effect. For now I'm just setting it up. It's is printing, which is going to be false by default, and then over here we do is sprinting is equals to input dot is action pressed. Basically, if we are just holding the button, and this is going to be sprint, which is our shift key. So if it's true, then sprinting is also going to be true, and then based on that we can get the speed. So what I will do here is that I will define a sprint speed variable. Let's call it sprint speed. and I will have its value to be 20. So now if we are sprinting, we will return sprint speed, otherwise we will return the default speed. And then over here, instead of multiplying it by speed, we are going to multiply it by get speed, and same over here. So yeah, this is it. And now if I run the game and I press shift, so now the player is able to sprint ahead with increased speed. And yeah, one more thing I would like to point out is that while running the game, you may observe a little bit of jitter, and it is observed on different PCs differently. Sometimes you may not experience a jitter, and that's because of the fact that the physics process function runs on a fixed tick rate of 60 hertz. But say your monitor has a different refresh rate, say 144 hertz, or even if the game runs on a varying FPS, then there will be a mismatch between the physics process and the process of, for example, the camera's input update function, which runs per frame, like in underscore process. Okay, so for that, to fix that, what we have to do is go to project, and in the filter settings type in physics interpolation, and you can see it is inside the physics tab and 3D section. And I'm sorry, it's beneath this, which is common, right? So it's over here, physics interpolation, and just enable it. And what it will do is it does the magic behind the scenes, and so now the physics process is going to be synced up with your monitor's refresh rate. So now if you run the game, it's going to appear smoother. So yeah, that's one thing which is essential to do, because it is recommended to not call it in process. I mean, if you just called it in process, then there won't be any issue, but it's recommended to call the character bodies code in physics process. That's why we are enabling physics interpolation. So this is it for this tutorial, in which we have made the player controller. And in the next series of tutorials, we will finish the game and make it similar to the one which you saw at the start of the video, which is the end result of this project. So yeah, so by the way, thanks for watching the video. And you may have noticed that in this video I am speaking live. By live I mean speaking without a script. So it's recorded, but I have definitely added cuts, but I haven't added any script. So it's basically an attempt for me to speak naturally, and also because writing scripts and like that is a really lengthy process and I don't like it. So I just want to try out how is it really going to be when I speak like this. And also I'm not very good with like I don't have a habit of speaking while I'm doing something. So this is something which is also a little bit of hard for me, but let's see how it goes. Let me know your thoughts on it. And for this tutorial, let me know if you have any doubts or have any feedbacks. I will answer your questions in the comment section down below. So yeah, I will see you in the next video. Bye.